I want to thank you all for joining us today as we present our webinar covering the US EPA's recent changes to the AERMOD modeling system. For those of you who are not familiar with the AERMOD modeling system, it's the preferred air quality model for near-field impacts that is within 50 kilometers of a source release per the Guideline on Air Quality Models, which is also referred to as Appendix W. The model and all of its components are developed and published by the United States Environmental Protection Agency. And as you can see from the image there on the screen, AERMOD itself is the air dispersion model, where you input the sources, their emissions, the receptors where you would like to calculate concentrations or deposition fluxes, and it performs the dispersion calculations of whatever pollutant it is you have of interest. But it's also made up of a number of different components, such as AERMET, which itself has preprocessors, air surface, and AERMET. And in AERMET, you input raw meteorological data and you get out formatted meteorological data files for use within the AERMOD dispersion model. AERMAP is used for analyzing terrain elevations and a value which is also known as the hill height scale for analyzing complex terrain. And then there's an executable BPIP-PRIME, which analyzes point sources and buildings so that it can analyze the effects of building downwash on the plume rise from those point sources. So all of these executables work together to make up the AERMOD modeling system. Now, back on August 21st, the EPA published updates to the executables and source code for AERMOD, AERMET, and they released a draft version, a new release of BPIP-PRIME, which had not been updated in quite some time. These versions were all dated 19-191, and if you're not familiar with the numbering system for EPA modeling versions, the first two digits are the year of the release, and the last three digits are the Julian day. The previous release for AERMOD and AERMET was 18081, so it had been a little over 1 year since we had had an update from them. And of course, 19191 is same backwards as forwards, nice and easy to remember there. So let's take a closer look at the changes that happened within each of these models. And we'll start with AERMET because this is a pretty simple list of changes. It was just a series of bug fixes. These are not going to cause any consternation or trouble for those of you who are working with AERMET projects. It's a very simple fix to update your existing SFC and PFL files with the new model executable. And here is the list of the bug fixes that were implemented. There was a correction applied for skipping various days when dealing with output from the MIF processor. For those of you who haven't heard of MIF, it is used to format output from prognostic meteorological models such as WRF and MM5 for use within air quality modeling systems such as AERMOD. There was also an audit applied to read a greater number of soundings, a fix applied for the TD3505 or ISHD precipitation reading from those data files that have hourly surface data. Some updated boundary checks on the first FSL upper air sounding, and then an on-site data correction. There was a stage 1 step that was not being aborted when there was some data missing the delta temperature heights, and that has now been implemented to avoid any strange error reporting later in the process. So again, all of these are just bug fixes. You can take any existing AERMET project that you have and immediately run the new AERMET executable with it to get the updated SFC and PFL files in the proper 19191 version. And we'll take a look at that within the AERMET View application in just a moment. Now, there were a lot more changes applied to the AERMOD executable. First, we'll take a look at the bug fixes, starting with background concentrations. There has now been a correction applied for the conversion of background concentrations to the model output units. There was a little bug that was occurring inside if you had modified the model output units but had not changed the background concentrations. These background concentrations are also now being excluded from calculations of deposition flux. For particle deposition, there's a modification made to the scavenging ratio for the method 2 option. We'll also hear about a change to the method 2 option coming up in just a minute. And a number of changes to buoyant line sources, including the imposition of now a minimum release height, which is 2 meters. Before, if there was a buoyant line source specified at ground level with a 0-meter release height, you'd pretty much get all 0 results. So there was something going on internally with the calculations that needed to be modified there. A minimum release height is now applied. You can also now use the ELEV unit keyword, which allows you to convert base elevation units from the default meters to feet. That conversion was not being applied properly to the buoyant line or line source types, so that has been corrected. And then a number of changes to errors and summary messages that are produced by the model, such as reporting of an incorrect NO2 conversion message, removal of the inadvertent adjust U star message when it wasn't meant to be used. There was an undefined fatal error with the low_wind keyword, and then some various reorganization within the code for people who had tried to run the compilation themselves. Sometimes it would fail depending on what compiler you were using. So all of these bug fixes are things that you don't necessarily have to modify anything in your project. You could just rerun them through the new AERMOD executable, and you would be able to run it a little more easily than you would otherwise. But there are some new features and enhancements to the model that we will now take a look at, including some new source types. First of which is the new R-line source type for modeling roads and other similar line type releases. Of course, AERMOD has not always had a line type release in it. The closest thing that it's had is the buoyant line source, which was implemented back in the 15.181 release about 4 years ago. But other than that, the line source type that existed within the model was really just a modified rectangular area source. Now with this new implementation, we have a true line source type algorithm within the AERMOD model. Now it is meant to be done as part of testing and analysis, as the dispersion calculations were taken from the existing R-line model, which uses the integrated contributions from points along a line to perform dispersion calculations of these emissions. Because it is a new source type, it does need further testing and analysis, which is why it's now included in the model. So it requires the beta keyword flag. So it is a non-default model option. It also requires the non-default flat model option to be applied. You can still incorporate the R-line source type into a project that has sources which will use elevated terrain, because the model does allow for the use of both some sources as flat and some sources as elevated when performing its calculations. So there is a lot of flexibility within AERMOD to use R-line with other source types. There's also an option built into the model now, rlemconv is the keyword, for converting R-line emissions in order to use the gram per hour per link as the emission rate instead of the default gram per second per meter squared or gram per second per meter, as we'll see in a second. This means you can take emissions from MOVES, the emissions calculator for mobile source emissions, and input them into the AERMOD model a little more directly. You won't be able to use deposition with this source type yet, but it does include NO2 conversion option, the ARM2 option. It also allows for event processing, and the urban processing options are all a part of this new R-line source type. An extension of the R-line is the R-line XT source type. Now, if you do want to play with the R-line XT source type, it will require the alpha model option. So the R-line source type being a beta source means that's a little bit closer to full incorporation within the AERMOD model, as opposed to an alpha option, which has not really undergone any sort of peer review process yet. But both of these have been included for the stakeholder community to test, to apply, and to learn from them so that they can provide feedback to the EPA on their use. The R-line XT source is different from R-line in that it has options for including barriers and depressions along roads to reduce concentrations. So you can see some examples here from the images, looking at the depression where the roadbed is some distance, some depth below the standard base elevation of the surrounding area, or the incorporation of the barrier. Of course, both of which, as you can see from the graph on the right, It shows impacts of no barrier versus a barrier, and the barrier helps decrease concentrations downwind from the roadbed source. Additional changes to the model, the method 2 particle deposition, as well as the gaseous deposition routines that have been in the model for some time as non-default options, have now been reclassified as alpha model options. So they've always been non-default. That doesn't change. But if you do plan to use method 2 or gas deposition with 19191, you now require the addition of that alpha keyword in your control pathway model options. This is just to signify that these routines, while they've been in the model for a long time, they need further analysis and testing. ARM2 has been implemented for all source types, including the line, buoyant line, and the new R-line and R-line XT sources. However, the PVMRM and OLM Tier 3 NO2 conversion options have not yet been implemented for buoyant line, R-line, or R-line XT, so keep that in mind as you model NO2. And the urban option was applied to the buoyant line source. That had not been the case before. Another major enhancement of this AERMOD 19191 release was the addition of some downwash formulation updates. The existing building downwash routines that work within the AERMOD model have not been modified in quite some time. The existing regulatory version of BPIP-PRIME, for example, is dated back to 2004, and there hasn't been a lot of modification of these routines. And so after a lot of work from the EPA's Office of Research and Development, concurrently with the Air and Waste Management Association's Atmospheric Modeling and Meteorology Committee, they've come up with a series of new formulation updates that can be tested using the alpha keyword option within AERMOD. So these options do require the alpha keyword to be applied, and there's two sets of keywords that can be applied here. The first, ORD underscore downwash new, and then AWMA downwash new. The ORD model options, you can see here, there's three keywords that can be applied: ORD UF, ORD TURB, and ORD CAV. And each of these does something a little different. The UF option redefines the height of the effective wind speed. The turbulence option decreases the vertical turbulence intensity within the model. And the cavity option for ORD shifts the downwind points where the vertical and lateral coefficient growth begins downwind of the wake. For the AWMA options, there is a similar effective wind speed option for redefining the height of the effective wind speed. That option, AWMA UF, cannot be used in conjunction with ORD UF. You have to pick one or the other, but the other options can be played with in concert with each other. The AWMA U-TURB option defines the effective parameter bound definition, makes some modifications internally to those, and then there is a streamline keyword applied to the AWMA options, which reduces the dispersion in the wake of streamlined structures such as tanks and or cooling towers. So there are a lot of internal options that you can play with here. You don't have to select a lot of numbers or make a lot of definitions. It's really just a series of checks on or off for these different options, and you'll be able to see how these updates in the downwash formulation impact your results with point sources and building downwash. In conjunction with these downwash formulation updates, there was a new BPIP-PRIME executable released by the EPA. This is a draft release. It is specifically numbered 19191_DRFT, and it is for testing and review purposes only. So it does not replace the existing regulatory version of BPIP-PRIME, which is dated 04-274. So if you're doing a regulatory analysis, then you'll be using 04-274. But for those of you that wish to test these new downwash formulation options, particularly the ORD options, this new BPIP-PRIME will be of use to you. The main update within its formulation involves the effective along flow length for rectangular building tiers only, those of which are angled to the wind direction. And you can see from the image at the bottom, it's the differences between 04-274 and the new 19191_draft. So you see the dotted line, the dark gray, and the light gray building tiers here. The light gray would be the actual building. So how it is oriented to a normalized wind direction here, 15 degrees, 30 degrees, 45 and 60 going from left to right. So that is how the actual rectangular building tier appears. The dotted line surrounding those different use cases is how the current BPIP-PRIME projects the along flow length of those buildings. You can see it's quite large because of the way that it expands that along flow length. But the new BPIP-PRIME, this draft release, is actually this dark gray building is how that's going to be modeled. You can see how it grows a bit with each change in the wind direction, but it doesn't grow quite to the extent that the old BPIP-PRIME projected that along flow length, thus helping to improve the overall categorization of building downwash in those cases. So using this new BPIP-PRIME draft release with some of the new downwash formulation options in the model will help bring about a little more consistency and a little more accuracy, hopefully, to the model results.